Extensive and intensive quantities. Now, this is a pretty defined difference between two quantities, and the quantities that double when we're doubling the number of items um, are called extensive quantities, and the numbers that are unchanged when we doubles the particles, the amount of stuff, are called intensive quantities. So, first of all, what are the quantities that we're talking about? Well, we can have volume, number of particles, the entropy, energy, enthalpy, how much energy, temperature, pressure, mass, gives free energy, um, mu as chemical potential, and then density, rho. So, for example, whenever we double the number of stuff, does the volume doubles? Well, yeah. So our volume is an extensive quantity. What about the number of particles? Well, of course, when we double the stuff, for example, instead of a pen, we have two pens, we double also the number of particles. How about the entropy? Yeah, when you know that with higher number of elements, we also have a higher entropy. Energy, of course, increases as well when we have two elements, because of course there's a value assigned to each one. Same thing for the enthalpy, because it's related to the energy. And then the temperature instead changes. Well, if you think about this, when you have one object or two objects, does the temperature change? No. The, the object will have the same temperatures. For example, if you have a pen or two pens, does the temperature in the environment change? No, it's the same. So temperature is an intensive quality. How about the pressure? Well, if you have two pens instead of one pen, again, the pressure doesn't change. If you have instead, if you're talking about then the mass, well, of course the mass changes when we have two pens instead of one. The total mass doubles, in fact. Then we have our Gibbs energy that, of course, increases because it's related to all the things that we talked about until now. Um, oh, I skipped the Helmholtz energy, which of course increases as well because it's again related to the energy, U. And then we have our chemical potential, which does not increase. If we have one pen and two pens, the chemical potential is going to be the same per pen. Then, oops, okay. Then the last one is the density. Does the density change? Well, if we have the density, if we have, for example, two pens, the density does not increase. We're occupying more volume with more mass. So density remains the same. So it's going to be intensive quantity. Now, one thing that you want to learn or you want to remember is, I'm sorry, what happens when you do math with these? For example, when you do extensive, sorry, times intensive quantity, what do you end up with? Well, I can think, for example, an example which is S times T, and you end up with a an extensive quantity. Uh, we know we end up with G, for example. If we have dg, constant volume, constant number of particles. Instead, if you have, oh sorry, and also if you take the division, so you do extensive divided by extensive, oops, you're gonna end up with an intensive um, quantity. This is pretty much it. All you need to remember um, from this section. It's not much, and it's not very hard. So, um, as long as you remember or at least understand how to determine if something is extensive, intensive, then you're good.